Hello, everyone, and welcome back to another episode of Solidity Fridays. Today I'm joined with Rebecca of Linum Labs and a really impressive developer called Sam. Hey, Sam. How are you
Hey,
doing?
I'm doing good, thanks. How are you, Tom?
Yeah, very good, thanks. Having a nice Friday.
Yeah, Friday, I think we call
Friday.
it. Yeah.
Because it's Solidity Fridays, of course.
Yeah. We should call
Um,
it Friday, Solidity.
okay, we'll call it Solidity Fridays. Sam approves of Solidity Fridays.
Fridays
Today we're
every
going to be
lesson.
covering Alchemix, which is the first same asset self-repaying loan product in DeFi. And I asked Sam to join today because he knows Alchemix quite well. He's actually taught me a lot about it. And I thought he was the best person to show us around because he's building something a bit similar to Alchemix.
Yes, yeah, exactly. So we're building an app modeled off Alchemix called Coffee Money. So it's COFI.money. So yeah, keep an eye out for something Alchemix related.
All right.
Awesome.
Cool. Let's dig
Cool.
in.
Cool, Tom. Do you have the screen ready?
Yeah.
Perfect. Switch over there. Over to you.
Oh, that's not good.
No, it's not very good, but this is Alchemix on DeFi Llama. At the moment, they have a $50.74 million TVL. Their historic highest, I don't know which was this one or this one. It's this one. Was really high. It was
Oh, wow.
889.51 million in 2001, and then also it stayed around 800 million through to 2022. So yeah. But if you include the staking, then it's slightly higher. Not much.
Okay.
An extra 7.91 million. It's considerable, actually.
Mm.
Alchemix is a DeFi protocol that allows for the creation of synthetic tokens that represent the future yield of a deposit. It enables users to retrieve near instant tokenized value against temporary deposits of stablecoins. And it was audited by, I can't see. Yeah.
Oh, that's a loss of Alchemix.
Yeah. And then here's their website. It's just alchemix.fi. So yeah, you deposit collateral, then you earn yield, and then you can borrow your future yield or spend your earned credit or save your earned credit. And there's more information on that, but I don't know if we need to dig into that too much. Oh, those are the developer docs. So I think, are these the only assets they accept, Sam?
I think so. I think they have support for Aave as well as Yearn Finance. So I think it's Yearn Finance, maybe another one. Yeah.
Awesome. No liquidations in Alchemix. That's something to note. No matter what happens, they'll never liquidate your deposit. But you can choose to self-liquidate your own loan at your own discretion.
So just to a word on the liquidation. So it's non-liquidatable is because if you think you're borrowing ALUSD, which is a USD token, against your USD deposit in Yearn Finance. So if you think the value of USD was to go down, they're always going to be that kind of same ratio. So there'll never be a situation where there's going to be a liquidatable occurrence. Basically, what we mean when we say liquidation free is if you're borrowing a derivative of your collateral, then they're always going to be like moving in sync together, like
in like a ratio
in price. Yeah.
Okay, cool. Yeah, thanks. That's good to know. Awesome. I don't know if you want to mention anything else before we dig into the code.
One interesting thing. So you can borrow USD, so our USD and our ETH. So on their YouTube, actually, they do have like these really nice kind of like movies which tell you like how would I long ETH, for example. So I think what you would do is you deposit ETH into Alchemix, so you have like this yield-bearing ETH, and then you'd borrow our ETH and use that our ETH, exchange that for more ETH, and then recycle that ETH back into Yearn. One common strategy that the Alchemix user, they recycle this, they do this kind of recycling where you're borrowing our USD against your yield-bearing collateral in like Yearn Finance, and then you exchange that our USD for USDC that you then kind of deposit back into Yearn. So what you can have is this like leveraged exposure to the Yearn Finance APR, basically, in a way that is liquidation free. So you don't have to kind of worry about being liquidated in like other kind of lending protocol. With your exposure to DAI, for example, that would put you at risk of liquidation. So you can, in effect, leverage your exposure without fearing any kind of liquidation, essentially, in Alchemix.
That's so cool. Wow.
Yeah, really, it's
really
really neat, really neat project. Yeah.
They have nice developer docs. So if we get stuck on anything, maybe we can check these out. But yeah, let's look at the GitHub. So
I think the GitHub is obviously very big project and lots of smart contracts. One place I like to start, if it's like smart contract system, is what is the kind of initial point of entry for the user. I think that would be, they have this Alchemist v2, so that might be like a good place to start.
Okay, cool. Cool. I don't know if there's anything in the README. Nope.
Oh no, I can't see it now.
Oh, cool. Cool. Wow, there's lots going on in this repo. Gosh. So like you're saying, where's the user's first point of entry out of these?
I think it's in the Alchemist v2 contract, I think. That's
Cool.
kind of like the heavyweight contract. And yeah, I'm pretty sure this is like a very long contract.
Yeah, it looks very long. Look how small my little scrolly thing is.
Yeah, wow.
Cool. So this inherits iAlchemist v2, initializable, multi-call, and a mutex. Interesting that they use the mutex lock. That's cool. I'd love to know how they did that, but I feel like that would be a tangent that maybe I could do in a different episode. Then they import this library limiters, and particularly the linear growth limiter. And then they're using another library called sets for sets.address set. Cool. Oh, Sam, you like dark mode, don't you?
Oh, I'm fine. I think I need light mode to wake me up a bit. So
okay, cool.
This is fine.
Okay. So they have a struct for accounts. So each user will have an account. They have a debt, which is an int, so it's a signed value, which represents the current amount of debt or credit that the account has accrued. Positive values indicate debt, and negative indicates credit. Then a mapping of balances, which is the share balances for each yield token. Last accrued weights, the last recorded values recorded for accrued weights for each yield token. What is an accrued weight?
That's a good question. I think it's basically their mechanism for kind of like checking on the yield being generated, because I think at kind of like set intervals they're going to have to update the yield being earned in Yearn Finance and like reflect that in this kind of account. So I think this last accrued weights is to do with the kind of yield accrual kind of the account, but perhaps we can kind of dive into that and like harvesting and stuff. This one thing I think it's interesting. We have this int 256 debt. So you see the comment above says positive value indicates debt. whereas negative value indicates credit.
That confused me at first.
Yeah,
I would have done it the other way.
That's interesting because I think like when you instantiate an account, saying is, I'm not sure whether you kind of start with like a 0 or you start with like a positive like number, which indicates that you have credit in a way. So yeah, interested to kind of like learn a bit about that.
Yeah. Cool. Then you have a sets.address set deposited tokens. So this is the set of yield tokens that the account has deposited into the system, and they're quite a few.
That's interesting.
Yeah. Then allowances for mints and withdrawal allowances, which is a nested mapping. Cool. Basis points. So yeah.
10,000. So the basis points, 1 basis point is 1%. So what we're saying is this is kind of like the granularity of a basis point. So it's when you're kind of like doing some kind of like multiplication, or when you want to find like what is like 5% or something, then usually do is you can't divide fraction left over. So what would happen is you would multiply it by, I think you multiply it by 10,000, and then you if it's 5%, then you kind of then I think you multiply it by 5 and then do like divide by 10,000, I think, or something along those lines. If you're trying to like find a percent. One, I was actually dealing with the percentage in our smart contract, and one good library to do for percentage math is there's one in the RV2 contracts called percentage math, and it's like a really neat way where if you just have some kind of like, say like 100, what you just do 100% mol, and then you type in this kind of like basis point. So if it's like 50%, you just type in 5,000, and then that will just give you whatever that number is times by 50%.
That's awesome.
Yeah, it's really, I find it like super handy. Yeah, so yeah, that's really cool.
That's awesome. I've seen you using it actually. So it comes from RVV2.
Yeah, I think it's in RVV2. If you look at their contracts, they use that kind of percentage math. That's super handy.
So I see in Alchemix here on line 54, they're doing their own fixed point. So that's basically what you know. So everyone should probably watching knows that 1E18 is a pretty common fixed point scalar. Cool. I wonder why they have a version. Is Alchemix upgradable? I don't think it is.
The kind of normal kind of proxy pattern, transparent,
upgradable. They do have a transparent.
Yeah,
okay,
I'm pretty
so it is
sure they do.
So that's probably where this version comes in.
Okay, that makes sense.
Debt token, admin address, pending admin address, sentinels. Unfortunately, they put their documents in the interface.
What we could do is if you maybe in a separate tab you could open their kind of interfaces, because then that has like all the comments for each of those. Yeah, I think that because the inherit doc is useful, because sometimes the nat spec kind of comments just become a bit kind of too much, where it's just like 90%
they do sometimes become too
nat
much.
spec. Yeah.
Okay, wait, this isn't. Oh, V2 state.
Interesting.
Where is that?
Oh, there you go.
Cool, it has a struct, underlying token params. So there's uint8s of the decimals. Uint8 should be big enough, because you're not going to get more than like...
yeah, more than 16?
Yes.
Or is it 64?
It's 64.
Yeah, 64, yeah.
Then a conversion factor, which is a coefficient used to normalize the token to a value comparable to the debt token for example, if the underlying token is 8 decimals and the debt token is 18 decimals, then the conversion factor will be 10 to the 10. Okay, cool. One unit of the underlying token will be comparably equal to 1 unit of the debt token. That's a cool way to do it, actually. I've worked with different decimals before, and I guess I kind of did. I did do a conversion factor myself, but I didn't save it as like a nice variable in a struct.
I think this is important for Tether as well, because I think Tether has like a different number of like decimal places to other ERC20 tokens. I think so. I think
yes, and
especially
USDC has 6.
Oh, USDC has 6. Yeah,
yes.
yeah, true. Yeah. So yeah.
Yeah, it's really clever that they did that. If they didn't, they would have mad math errors and it wouldn't have worked.
Yeah.
And then they have a bool enabled flag to see if the token is enabled, so they can disable that. Then they have the yield token params. Why do you think that they put these structs in the interface and not in the actual contract? Because we have a bunch of state variables in the contract itself, except these 2 structs.
That's great. That's a good question. I
Maybe
think
multiple things inherit this.
Yeah, it could be just like a neat way to kind of organize data, because sometimes you have like multiple smart contracts and they might be kind of the same kind of like data types and stuff. So if you just have like holds all your data types, then that could be handy. I guess that's also true for the diamond standards, which we're doing.
Yes.
Coffee money. So
yeah,
interesting parallel there.
Yeah, it is an interesting parallel.
Yeah,
with our app storage, it's like this interface. Cool. So they have the decimals, underlying tokens. So every yield token will have an associated underlying token that you can redeem for the yield token. An adapter, that's an address. So that's the one used by the system to wrap and unwrap and look up the conversion rate of this token to its underlying token. That's very important. Hopefully we can look at some adapters today.
Yeah, the adapter is really because I think we have different adapters for I think compound. So it's quite interesting because they have all these different adapters, but then this is also what ERC 4626 is solving by having that kind of standard interface for interacting with those smart contracts. So it's quite interesting how this kind of adapter piece, how they're kind of having to make these like custom kind of ways of interacting with these contracts. When ERC 4626 that's will be providing like much needed just kind of like uniformity to kind of interacting.
Like one standardized adapter substitute.
Exactly. Yeah.
Maximum expected value, credit unlock rate. That's the percentage of credit that will be unlocked per block. And it's an 18 decimal fixed point integer, unsigned integer, active balance, harvestable balance, total shares, expected value, pending credit, distributed credit, lost distribution block, accrued weight. So that's what you were explaining earlier. That calculates how much credit a user has been granted over time. The representation of this value is an 18 decimal fixed point integer and enabled. So you can also, with yield tokens, you can enable and disable them if you're Alchemist.
Awesome.
Cool. These are for the functions. I assume the mappings and stuff are down here, but I don't think we need to go to the inherit doc for.
Oh yeah, I guess it's kind of neat
for these mappings.
This has all the function signatures, so just like the names of the functions with like the comments. I guess, but the Alchemist v2 has like all of the like function logic and stuff. So
and the implementation stuff, yeah. I could make it like 2 halves, but I don't think we need to.
I think we're okay just like going between. Around. So I think the first point of entry is going to be the deposit underlying function, if I'm not mistaken.
Cool. So they have a blank constructor that's just an initializer.
Yeah.
And then they have a bunch of getters, and is it supported? So that just returns the bool. And then let's find that deposit underlying. All right, I'll just actually search for it. There you go.
Oh, very good.
Yeah, it's quite low down. Cool. This takes in an address of a yield token, an amount, a recipient, and a minimum amount out. So would you mind maybe explaining what deposit underlying does and how it returns the event 256 and what that is? Oh, this is where the lock comes in. That makes sense.
Oh, nice. So deposit underlying is when so by underlying, they mean the kind of that's going to be deployed to the yield source. So for example, like USDC or DAI or USDT. This only whitelisted. I think this it does. Is it actually isn't? There's not like a whitelist as in, oh, you're whitelisted to use this function, but rather I think it prevents smart contracts interacting with this function, which is quite interesting.
Oh, that's clever.
I think
so it probably checks the code size.
Yeah, I think that is literally what that function does. I think in terms of what I think the main reason behind that to prevent against any kind of exploit that would only be possible from a smart contract, I believe. So this could be like a good kind of like countermeasure to kind of any kind of someone kind of setting up a kind of malicious smart contract to kind of exploit. I think that was actually how Euler was hacked last week, was someone had actually deployed a malicious smart contract to do this kind of to kind of exploit this kind of math error in the Euler contract. So this could actually be like a good, and if your application is only ever intending for actual kind of human users to interact with it, then this could be like a good addition to your functions against any kind of exploits potentially.
Absolutely, that's so good to know. I might actually quickly look at how they do it. I assume they just like if code size is not 0.
Or it could be the case that isn't actually why they have it. In which case, I've just got.
In which case, you just came up with such a cool idea. Here we go. Oh, it's a function. I thought
here
it was a modifier. So yeah, if checks if the message sender is an externally owned account. In the future, this potentially may break. It is important that functions which rely on the whitelist does not be explicitly vulnerable in a situation where this no longer holds true.
I see. Okay.
Oh, so it just checks if the transaction origin equals the message sender.
I see. Okay, that's interesting.
But
so
if there's a call from contracts, then they check the whitelist here.
Okay, so I think I guess this is like another way of checking if they have a contract size, or maybe if the message sender has a kind of allowance to move functions, perhaps to move tokens, maybe.
Oh, I see. Actually, what I think it is it's kind of what you said earlier, that most contracts can't. So any externally owned account can just proceed, but if it's a contract, they only whitelisted a few contracts, and those contracts are either authorized or unauthorized.
Okay, that makes sense.
Yeah, that's really cool. Take argument that recipient is not equal to address 0. Cool. And then check that it's a supported yield token. So that's probably going to check that it is enabled, I would assume.
Yeah, I think so. Yeah. And then they're doing this wrap. So basically what this wrap does is wrapping the underlying token into the yield token. So for example, it's wrapping DAI into YV DAI, which is a token you get when you deposit DAI into Yearn Finance. So this wrap operation is basically what's kind of doing the actual kind of depositing into, I guess, or it's doing that kind of transformation. I'm not sure if underscore deposit is actually doing the deposit action.
Should we look at this wrap and see if that's where the deposit action happens? Or so deposit only deposits the yield tokens, not the underlying tokens. The underlying tokens rather get wrapped into the yield tokens first, I think.
Oh, I see. Yeah. So I think, yeah. So this is just doing the wrapping exercise. Yeah, so that might be good to look at wrap there.
It wraps the amount of an underlying token into its yield token. So this is the address of the yield token to wrap into. This is the amount, and then the minimum amount out that you're expected to receive from the operation. So that's obviously to protect against some slippage. Internal, that's pretty safe. Returns EUN256. So they're actually accessing the yield token param struct that's in storage and copying it here to a new storage slot. And then they're pushing to the mapping this yield token that you put in. They instantiate an instance of iToken adapter with the adapter address. Where does it get from the yield token params? I see. That's where you get the adapter address. Pass that into the iToken adapter. So now we've got our adapter, which will obviously depend on which yield token you choose. So it might be EARN, let's say. And then address underlying token equals, you get the underlying token for that token params. Then you safe transfer from the underlying token from the messages.sender to this address of amount. And then your adapter.wrap amounts and address this. So we might actually want to look at this adapter contract in the wrap function. I don't know. Maybe later. And then that gives you wrapped shares. And if that's less than the minimum amount out, then revert, don't do this operation. We're exceeding our slippage.
Yeah.
Otherwise, return the wrapped shares.
Yeah, and this minimum amount out is important because if that wasn't there, and say for example there was like a large slippage in whichever yield venue you're interacting with, so if a transaction completes, then that kind of slippage is made permanent. So say for example you deposit like 1,000 DAI and the slippage is like 10%, so you'd only get 900 kind of equivalent YV DAI out of that transaction. So obviously, if that's the case, you want to prevent against that transaction from finishing its execution. So you know it's going to be, and that you're kind of happy with what that output is, rather than have that kind of transaction go through, and then you're kind of just left with that kind of slippage, basically. So that's a neat kind of addition to kind of unwanted like output, basically.
Yeah, that's really good. And then they also have unwrap, which will probably just do the same thing but in reverse. So you need an adapter for this again. Then you call adapter.unwrap, and then again you have a minimum amount out and a slippage exceeded if you do exceed that minimum. If you get less than the minimum.
Yeah.
This is something that you mentioned to me once, or you pointed out, this poke function. I don't know if we would get you if we scroll all the way down and go through all the functions. Maybe we discuss it now.
I think, yeah, so this poke function is a kind of symptom. The reason we have it is because contracts aren't autonomous systems. So in order for something to update contract, there has to be a state change. So you have to basically write to the blockchain to kind of initiate that state change. So what this poke function does is it provides a way for the system to kind of like update some kind of like variable or some kind of state kind of pertaining to like the kind of operation. And because say you're Alchemix and you have, you know, like a multitude of users, there isn't a way to kind of subtle things you can do with like maths. So this kind of like per block. So for example, they're using this kind of like block.timestamp for things such as the credit, is because you can, when you're kind of reading data, what you can do is just apply this kind of block timestamp to some kind of constant, and then that way you can kind of decide your yield generated at that point in time. But I think the way this poke function is used is that whenever a user submits a transaction to Alchemix, this poke function will update the kind of state of that user's like account for example, to reflect like the most kind of recent like version like of that, basically.
Okay, very cool. It's interesting because earlier when we were looking at the directory, I saw that they had under adapters, they had a folder called keepers. But it's just interesting that they're using keepers and a poke function, because keepers kind of, I would use it to do in essence a poke.
But yeah, I think this poke is more on like a per user kind of like operation. So it's only kind of pertaining to like a specific user, whereas the kind of like the keepers is more of a kind of like a system
for the system-wide
kind of like update.
Okay, thanks.
Yeah.
That wasn't clear to me. I think you're right.
Yeah.
Right. Cool. Maybe we look at, and then after calling wrap, it calls the internal deposit function. But this is, so you're depositing the yield token now. After you've wrapped the underlying into a yield, you deposit the yield. Oh no, that's not the actual function. Here it is. Cool. And yeah, this just takes in the yield token, amount and recipient, checks that amount is greater than 0. Yeah, make a new storage variable called yield token params and copy the value of this mapping when this is the key. And then you get the address of the underlying token from that. And then you check that it's enabled, check that underlying is enabled, and check loss, which assures that the token has not experienced a sudden unexpected loss. This prevents users from being able to deposit funds and then have them siphoned if price recovers. Okay,
that's interesting.
I almost want to see what it does.
Let's take a look at check loss. Yeah.
Oh, I didn't. Sorry. The L key on my laptop is not really working.
Oh no.
Cool. So it calls a function called loss on the yield token, and then it gets the maximum loss. Oh, and if loss is greater than maximum loss, revert. Okay, that was a lot simpler than I thought it would be.
Okay, that's cool.
And this loss probably just returns the loss.
The loss. Okay. Should we take a look at loss to see how that's returning back? That would be interesting. Okay.
The ternary, and it says
Oh, nice.
If expected underlying value is greater than amount underlying tokens, then yeah.
So if it is that, then
it's 0.
So if the expected underlying value is, so we have the amount underlying tokens, which is convert yield tokens to underlying.
Yes.
So that's, say you have like because the number of YV DAI you deposit is just going to be a fixed number, which doesn't really mean too much. It's just kind of the amount of shares you get back. So like you could deposit 1,000 DAI into Yearn Finance and you might get, say, like 800 YV DAI, but that kind of 800 number isn't really important. What is important is the price per share in Yearn Finance will trickle up over time as that vault is earning yield. So that's kind of what is like the part of that. So I'm pretty sure that share tokens, they're minted, you get minted the same, but as the vault is earning yield, then the share tokens will kind of trickle down, I think, over time, but maybe don't quote me on that.
I think you're right though, but yeah, that's
in terms of like the actual number of share tokens you
so then that's what amount underlying tokens is. You get it from here, and then if the expected underlying value is greater, then you return expected underlying value minus amount underlying tokens times by the basis points, and then you explained this earlier, and then you divide it by the expected underlying value, so you can kind of get how much loss has occurred. Otherwise, return 0.
I see. Okay.
Cool. We were on internal deposit though, I think. that's not how you spell deposit. Well, neither is that apparently.
Oh, huh. There you
go. Then they call preemptive harvest.
Yeah. So I think this is to do with it's when you're kind of making a deposit action, it wants to harvest what the pre-existing deposit is. So that way, when you're kind of, I think what this prevents is that, say you kind of like deposit into that you don't suddenly kind of capture someone's yield who has kind of deposited like prior to your deposit. I think that's the purpose of this. So what it's doing is it's updating the total kind of like yield earned before kind of officially kind of adding your deposit, so that that's kind of up to date with like, so when you actually add your deposit, the system is kind of like fully up to date with your rewards, and you're not kind of piggybacking off of like someone else's reward, if that makes sense.
Wow, very clever.
I think I'm pretty sure that's what it's doing.
Do you want to look at it, or you want to?
Yeah, we can take a look. Yeah.
Wow, it gets called a lot before any kind of. Cool. This is preemptive harvest deposited. It calls this function cool. This will earmark yield tokens to be harvested at the future time when the current value of the token is greater than the expected value. The purpose of this function is to synchronize the balance of the yield token, which is held by users, versus the tokens which will be seized by the protocol.
Okay, that's interesting.
That is interesting.
Because I take a 10% management fee, I think. So perhaps
that's
this
quite
is
high.
also, yeah. I thought seem not really too sure like whether that's high or not. I think like a normal portfolio manager takes like around that. I think like in like Withdrawals.
Oh, okay.
So maybe that's like how they landed on.
Maybe it's fair, yeah. So they get the active balance. If it's 0, then just return. Otherwise, you get the current value doing that function you explained earlier. And then you get the expected value. And if current value is less than or equal to expected value, you return.
I see.
Then you get the harvestable, which is this again. If that's equal to 0, return. Otherwise, reduce active balance from by harvestable, and then the harvestable balance of that yield token in that mapping gets increased by the harvestable amount. Okay, that makes sense.
Okay, and this harvestable balance, is that just Alchemix who is eligible for that harvestable? I think.
I would imagine so.
Yeah.
So this is
okay.
probably Alchemix, and then this is probably the user.
So this is how they're kind of.
Fees. Interesting.
Oh yeah, that is actually really neat. Yeah, so this is how they're kind of tracking who uses Alchemixes and which is the users, because I think you just have this kind of like pot of like tokens. So I think you're having to kind of like check like who's like, so to speak.
Okay, so cool. So they call that preemptively harvest the yield token. Then they distribute unlocked credit deposited.
Okay.
Oh, then they call that poke that you explained.
Oh, nice.
I don't know if we should look at this distribute unlocked credit deposited. I'm not sure what it's doing. I assume, oh, I see. So you've deposited in and now it's unlocked and you can distribute that credit back. I don't know. Maybe that's what I assume, but.
Yeah, I think it does kind of tie into the preemptively harvest, and then that would kind of follow, as in they know what is the balance held by the users and balance of Alchemix, and then once they've done that, they can then kind of distribute that credit to the. It might actually be good to take a look at this, because I think this could be quite an important function.
Gets called a lot.
Yeah.
Oh, was that it? No.
Okay.
Oh yeah, it is. So it first takes in the address owner, and then it creates a storage variable called depositor tokens, and it copies the depositor tokens of this owner. We saw that earlier. Those are all the deposited underlying tokens that one account has deposited. Then you go through it, through the values, that is, incrementing in the gas efficient way where the pluses come first. And then you call distribute unlocked credit.
Way then of
it's more gas efficient to go plus I than I plus plus.
Oh, okay.
So
I
didn't
know that. Okay, but that's good to know.
Yeah.
Cool.
Yeah, nice. And then, so for each I in that mapping, it distributes the unlocked credit, passing in that value of the deposit token. Maybe we should look at this. Oh, it's right here. So this is the actual distribution phase now. It gets it makes a new storage variable called yield token params, and it copies the other the yield token of value of the yield tokens mapping. Then it calculates unlocked credits for that yield token. If it's equals 0, just return, but otherwise the accrued weight plus equals the unlocked credit times the fixed point scalar divided by the total shares. Okay, that makes sense. And the distributed credit then plus equals unlocked credit.
I see. That's interesting. I think so. They have this like total shares parameter in yield token params. I wonder how similar that is to just like ERC 4626 in terms of how that's kind of doing the share calculation, because I guess you could almost have a version that is kind of based off of like 26 contracts entirely, as a way of kind of doing it. But I think with total shares is like Alchemix's like version of kind of tracking this like shares. I think.
Yeah, earlier when I saw total shares, I thought it was equivalent to like ERC 4626 shares.
Yeah.
But gone through an adapter instead of an IRC 4626.
I see, yeah, and I think that could also be like, I don't think 4626 was launched when these contracts were first developed.
No, I don't think so.
But I think like the fact that like, I mean, what you could do is you could just deploy a 4626 wrapper for each of these kind of yield, but I'm not sure if that would be like less than what they have with their adapter contract potentially. I know 4626.
It would be interesting to do gas estimates of both code and then see what is actually more efficient.
That could be interesting.
Cool episode, like investigating the difference between an adapter and an ERC 4626. Who's more?
No, definitely.
Gas efficient.
I know Morpho, who they have like this like Morpho RV, where they had this kind of 4626 with their contracts, and I think really gas inefficient.
Oh wow! So did they change it?
I don't think they changed it, but it was kind of like left and deployed. But when I tried to kind of interact with it, I kept getting these like gas kind of application stuff.
Interesting.
But yeah,
so the adapters might actually well be more gas efficient.
Yeah, maybe we'll have to do like an investigation into that.
I'm so keen. I would love to. That'd be a cool episode. And you get such nice gas snapshots in Foundry now. This is in Foundry.
Oh, really? Nice. Yeah.
You could just clone this code and run like add to the foundry.toml gas snapshots, and then just put a star, and then everything gets this gas snapshot. Cool. Then they call poke, which updates the recipient's account, proactively issues shares for the depositor tokens to the recipient, and then increases the value of the token that the system is expected to hold. Okay. Interesting. Then issue shares for amount. Okay, so this, if we look at this, we'll probably see how they get the shares.
Yeah, it's good.
It's only called the deposit function. Cool. So amounts must never equal 0. But they don't check for that. They don't have a require.
That's interesting. Maybe because it's internal,
Just
they're handling that in the
oh, it's
deposit
internal.
function.
Yeah, they probably handle it in the actual function.
Yeah.
Oh, they did check that. Remember, in the deposit function, the third thing they called check arguments, and then they said amounts greater than 0. So they have checked.
Yes.
Okay.
Yeah. True.
Cool. Makes sense. Cool. Then they convert yield tokens to shares. That's actually the function we want to look at, I think.
Mm.
Okay.
So if its total shares is 0, I think that's just if it has it as like a yield token that's been did on Alchemix, I think. So like I think there has to be like a way to kind of first issue shares. Maybe this just means that that's kind of the yeah, I'm not too sure. So we return amounts multiplied by the total shares divided by the unrealized active balance for that yield token. Okay. So I guess unrealized meaning, yeah, okay, yeah, that's a good shout. Yeah.
Not yet converted, yeah. Maybe. Wait, I don't want that. Just that. So it gets the virtual active balance, which is the active balance minus any harvestable tokens which have yet to be realized. I see. So it's your balance after harvesting, which is fee collection, I assume.
I see. Okay. Okay.
We saw something quite similar earlier when we looked at the distribute credit and calculated the credit. It's more or less the same code, it looks like, and you just return active balance minus harvestable.
Okay.
Okay, that's pretty simple. And then, cool, maybe we go back to the deposits. Wow, that's one function's taken a while, but you're right, it is the biggest.
Yeah, most of it.
Okay, now they call sync, passing in UADD, which I don't actually see. It must be a state variable.
You add, okay.
I think maybe, I don't know, let's see.
Maybe that's kind of, yeah, okay, maybe we can find just you add. Maybe it's telling it to add if it's like an unsigned.
Oh, as opposed to like u minus, yeah.
Maybe.
Oh, it's a function call, I see, and it just adds to.
It just adds two numbers together, I think.
Yeah, it does. It does. I'm just confused because.
Yeah, I think they have it
with any.
I think it's like their version of saying whether to kind of add or subtract an integer. Yeah.
I think you're right, and it's probably because your balance is an int and it can go positive or negative depending on if you have credit or not. So maybe that's that. Let's look at sync though. I'm quite keen. It's called fairly often. It takes in a yield token and amount and another function that takes in 2 uint256 and it returns a uint256.
So this synchronizes.
This returns that, and then this doesn't return anything. So it synchronizes the active balance and expected value of yield token. And then this is this function. Oh, I see. It's okay. Wow, I've never seen this before. So this uadd calls a function. It doesn't matter what the two parameters are because it's just saying it just takes a function in as a parameter. So this must be uadd returns add in the deposits, and then if you're withdrawing, it's probably going to be this function equals u sub. That's very interesting.
Yeah, that's really cool. It is that type then, because it is a function. So you're actually passing a function as an argument to another function.
But you aren't executing the function, you're just returning the function you add or you sub. Interesting.
Oh, okay.
That's really cool.
Yeah, wow, that's which function am I going to use? That's cool.
That's very cool. Instead of like creating two versions of the same function that just has like one with slightly different operation, you just create an if statement or a
Okay, cool. Yeah.
That's so cool.
So, and it's calling that operation. So that operation could be either you add or you sub. Okay, that's cool. Yeah. And because
then they take operation somewhere, I think. Right? Operation.
That's really cool.
So then they perform that operation. Wow.
Yeah. I think they're just flexing their coding skills. I think rather than have it actually be the best solution, it's just like a little flex, just to say, oh, by the way, I know I can do this.
In Solidity.
Well, I think we might be on the deposit.
Yeah, and then we sync, then you get the maximum expected value just by reading the struct. If the yield token's expected value is greater than maximum revert, otherwise you're good to go. You emit the deposit and you return the shares. Wow.
Oh, awesome. Okay, that's cool.
Wow, quite a meaty function. It's very cool. It calls a lot of other functions.
Yeah.
So now I've deposited my underlying. What happens next as a user?
I think what happens as a user, I guess, because you're kind of looking at the front, that would, I guess, update that kind of mapping. So that's interesting, actually. So where is it storing of the call? So maybe that's also in the deposit function.
Here.
Oh no, I think that's just checking if they're whitelisted.
Oh, you're right. Here, they do a safe transfer from message sender.
Okay, so that's actually doing the transfer. So maybe in that deposit
underlying,
function.
And then you call the
deposit so the reason deposit is when you want to deposit the actual share tokens, to say that you already have a position on, rather than have to redeem your USDC. This just enables you to just transfer them your YV position, and then they'll kind of do that for you. So
yes.
That kind of like wrap operation before, basically.
Oh yes, it does skip that. Okay. Right. They have a withdrawal function, which is quite quite simple. It checks only whitelisted, checks the argument is an address 0, checks that it's an enabled yield token, then it calls the internal withdraw, and then it does a safe transfer and returns the amount of yield tokens. We could look at this internal withdrawal. It's called quite often. So that takes in an address, the yield token, the owner, the amount of shares, and the recipient. Cool, we've seen preemptively harvest deposited. This one gets called a lot because it's really important. Then they call distribute unlock credit deposited. Okay, so it first does the syncing of state, and then it does the actual withdrawal later on. You convert your shares to yield tokens. So that goes the other way. Then you poke with the address of the owner, which burn shares from the owner's account, and then decrease the value of the token that the system is expected to hold. Then you burn our shares. That makes sense because now I don't have those shares.
Burn shares. Might be a good to look at burn shares, seeing what it's updating, which variables.
they copy accounts into a new storage variable. Then they go your balance of that yield token linked to your account minus equals the shares amount.
Okay.
Then yield tokens total shares minus equals that shares. And if now it's 0, then you remove yield token from your deposited tokens because you actually haven't deposited that anymore. You've removed it all. Okay, that's cool.
That's cool. Found out the other day was that if you have a mapping inside the struct and you've like populated that mapping with like certain data types, if you delete the struct, then that mapping actually still exists in the smart contract. So just by if you have a mapping in a struct that you've kind of put data in, if you delete the struct, that's kind of like housing that mapping. That doesn't mean the mapping is deleted. The mapping would still exist.
Oh.
So that's quite like an important like secure consideration to be aware of, is like just to be aware that that mapping still exists, deleted the structs. You also would need to kind of handle that kind of mapping as well.
Wow. Thanks. I didn't know that at all.
Yeah.
Very, very good to know.
I didn't know it until actually, yeah.
Rad. I love how much you can actually learn.
Yeah, on Twitter as well. I think Twitter's been like the best, just like learning random like solidity tips.
Yeah, that's so cool. Then they call the validate and passing in owner. This validates the owner's account to assure that the collateralization invariant is still held. That could be a good one to look at.
Yeah, definitely.
And then when you're done with the withdrawal, then they emit a withdrawal event and return the amount of yield tokens you've got. Amount of yield tokens left probably, or the amount that you, you convert your shares back into yield tokens. So that makes sense. You get your yield tokens back. So it first gets the debt, and if debt's less than 0, return, so that it has collateral probably. And then if debt is greater than 0, not equal to it, then the collateralization equals the total value of owner times by the fixed point scalar divided by the debt. Cool, that makes sense. So this total value you're explaining, like, because the yield, I'm trying to formulate a sentence and it's not working. But basically, I think this total value gets the like the empirical amount, not the share-based amount.
Yeah, so that's actually a really good point, because they're kind of talking in share tokens, but obviously the number of share tokens is fixed. However, the kind of like representing the share tokens will kind of trickle up over time. So what you need to do, and also the debt that's being a fixed number of tokens as well. So if say you have like 100 DAI and you borrow 50 ALUSD from that DAI, then now that kind of is going to be worth more, but you just still have like a fixed number of shares. So I think this total value is just getting like the actual kind of underlying tokens, and then it's checking how much debt has been issued, and then actually so collateralization would be Alchemix as it is currently. So that basically means that you have to have twice as much collateral as like the debt that's issued. Or every 100 you can borrow up to like 50 against that.
Okay, that makes sense.
Yeah.
And if the account is then under collateralized, this will revert with an under collateralized error.
Oh yeah, that is actually interesting because I think duration in which an account could be under collateralized is if they kind of say from 50%, so like 200% to like 400%.
They suddenly change that value.
I think if you revert back, but the ALUSD has already been issued, because it's like because they can't take that back. I think that's the only situation you would be under collateralized if a system is kind of like operating normally. Yeah.
I think you're right.
Yeah.
Yeah, that makes sense to me. Cool. And then here's the total value that they called in the validate function. It's public, so you can get it externally if you want. Total value equals 0 initially. Then they copy a new deposited tokens variable to storage from the deposited tokens of the mapping accounts with passing an owner as the key. Then they set a few things. So you go through the length plus I, and set the yield token to values I, and underlying token shares underlying amount underlying tokens, and then that's calling convert shares to underlying tokens. And then you add total value plus equals normalized underlying tokens to debt.
Okay, that's cool.
That probably has to do, maybe you're like go back, your vote from basis points into actual debt. I don't know. No.
Yeah.
Forget I mentioned
that could be.
points.
Yeah. Oh no, there's so much to cover with the Alchemix smart contracts.
Yes, maybe in a while we can do a part 2.
I think, yeah, definitely. I think part 2 would be good. One other component which is interesting is a transmuter component. So this is where you can deposit LUSD and actually slowly convert that to like DAI, for example. So it's actually providing you that helps to anyone who it helps maintain the LUSD, provides like confidence to people that if they because we can get into more detail, but if you're someone who picks up LUSD but you don't have an active vault, there's no way for you to kind of convert back to DAI outside of liquidity pools. And if you're getting an undesirable exchange rate, what you do is you can go to component and deposit the LUSD in there, and then you would receive a kind of one over time based on, so this kind of
Amazing.
helps.
That's so cool. I'd love to check it out.
No, definitely. I think that's
and
one
the adapters
for sure. Yeah, maybe we can do a part 2 and dig into that.
Yeah, awesome. Thank you so much for joining, Sam. This
also, no, it's been a
episode
pleasure.
of brought to you by Linum Labs.